focus on the creation, though we will be doing that in case you forgot. More so, it's going to be about what it means, like interpreting the information. Okay? So, just so that you know the names of some of these representations we're going to use. So the first one is a frequency table. So you see the different categories. Okay? You see the tally mark of the people in there, and then you see the totals associated with them. Okay? So that's a frequency table. It's just telling you how frequent that occurs. You can do that with quantitative data too by making groups. If I wanted to make a frequency table of height, I could group together maybe like people that were between this height and this height, like how many fell in this category, this category, this category. I might not want to do a frequency table with individual heights. Maybe if I had a population that wasn't very spread, then I would do, like basketball players or something, maybe they're all relatively like tall. So then I could just go from like 12 different things and see the categories there. All right, so second thing is a dot plot. It's kind of the same thing. It's just like dots kind of making the bar of how many are there. So you see the categories, and then you see the dots counting how many are there. Risha? Well, if you added them all up, that would be how many people they asked. And so they asked person, like, what's the type of pet you prefer? Here's your choices. And then they just tallied one answer per person of who they asked. Okay? So then here's a histogram. So it's similar to the other representations. You could turn both of those into a histogram. We are going to focus a little bit on histograms because later in the class we're going to be looking at curves. And you'll notice that your bars in the histogram make like a certain shape, right? Like here I have some low here. It rises, it goes up, and like this. But it doesn't go back low and continue over here. So those bars can show you a curving shape, which is ultimately going to help us study something else called the normal distribution curve in this class. Okay? So histogram has like chunked data. So the scores in here are from 60 to 70, 70 to 80, 80 to 90, 90 to 100. And then you can see if you had those same groups on a frequency chart, the height of the bar would be how many tally marks you had for that one. Okay? Or if you had those same groups on a dot plot, the number of dots would be how high you drew the bar here for the histogram. Okay? And then lastly, here's a box and whisker plot of science test scores. Okay? Notice that there's only one axis here, and then there are some important things that we are supposed to know about this. Okay? So does anybody know how they got 1, 2, 3, 4, 5 things here? They call this the 5-number summary a lot about the data. What 5 numbers did they look at to make these little dividers along our box and whisker plot? Lauren? Okay, so we have a minimum. Sorry, I'm going to change my maximum. Every once in a while, there might be, maybe there was a score way out here. Okay? Maybe you choose to leave it as your minimum. Maybe you put a little asterisk kind of looking little star there saying this was part of the data. I'm going to mark it for you, but I didn't include it in my calculations because I think it's an outlier and it's extremely away from the other data. Okay? And so this is the median, so the middle. Okay? And then they call this Q1 and Q3. You guys hear what Lauren said? What do those stand for? Quartiles, okay, because they help split it up into quarters. So basically, you order the data, okay, and if you have different pieces of data, okay, if you have different pieces of data, this is your minimum piece of data, or sorry, yeah, and then this is your maximum piece of data, okay, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, this is my median of my data. Then the middle of the bottom half of the data is my first quartile, and the middle of the top half of the data is my third quartile. Okay, so the median is like my second quartile. Sometimes they might call it that. Okay, so here there's 4 in here. What I would do is pick this, which is the average of these two. The middle of those two pieces would be my Q1, and the middle of these two pieces would be my Q3. So if there isn't an exact middle, you average the two things that are kind of where you want to be between. Okay? And you do that anytime, even if you were finding the median and there was only 10 pieces here, you would average the two in the middle to get the median. Okay? So if you're literally just ordering the data and splitting it up into little clumps, okay, how much much of the data is right here? What percentage of the data is represented there? Brooke? Good, 25%, because the median does what to the data? Splits it in half. So would you guys agree that 50% of the data is on this side of the median and 50% of the data is on this side of the median, right? But then if I take that 50% of the data and I split it in half again, I have now split it into 25% of the data, the next 25% of the data, the next 25% of the data, the next 25% of the data. So in your box and whisker plot, it's important to understand that no matter how big or how small of it looks, it represents 25% of the data. So there's the same amount of data, there's the same amount of students who scored in this area as there are who scored in this area. Okay? But over here, their scores were more spread apart. That's why the whisker is longer, right? It's not because there was more pieces of data here. It's because, say there were 4 scores in this section. They were spread between 54 and 73. There are also 4 scores in this section. They're just only spread between 90 and 95. That's why it's smaller. Okay? So that helps me know, like, oh, you know what? This doesn't look too bad because this is almost as big as the whole rest of the box and whisker plot, right? Between 75% of my students were scoring 73 and above. Only 25% were scoring below 73. Does that make sense to everybody, how we read that? Okay? So that's how we split up the data and how we look at it. Okay? You guys, we're going to see later the range of the data. We talked a little bit about this yesterday in the real estate example. What is the range of data? What will you be looking at if we were looking at range? Any ideas? Ashley? Good. Basically, how spread out is it? Okay, so the difference between the maximum and the minimum. So in this data, the maximum is 95 and the minimum is 54. So the range of my data is 41. Okay? The scores range somewhere between that area of 41 different scores. Okay? Does anybody know what the IQR is? Anybody remember the letters that this doesn't know? Okay, so the IQR is the inner quartile range. So it's still a range, so you're subtracting stuff. But this time you're not subtracting maximum and minimum. Do you know what you're subtracting? It's like it's a range of certain part of your quartiles here. Good. So you're going to subtract your Q3 minus your Q1. Okay? That's how you calculate the inner quartile range. So that tells you, why would people care about that, right? Well, it tells you the middle of your data, how spread out was that? Okay? So that could matter. If the middle was really spread out, that means that, like, I don't have a group of students in my middle consistently scoring close to each other. They're all over the place. So some are getting it, some are not. If it was really close together and it was on the low end, I might be like, okay, the middle group of my students, okay, are all scoring around this same low score. Or if they were close together and on the high end, I might feel better about that. The middle group of my students is all scoring between 73 and 90. That's fine. Okay? All right. Outliers. What are outliers? Michelle? Good. A point that is really far away from the data. And here's where we get into the gray area of statistics. What one person might consider really far away from the data might not be what another person considers really far away from the data, right? So sometimes people use this calculation to calculate outliers. To check if something's too small for the data, they do this calculation. If I do Q1, so that's this marker right here, and I subtract 1.5 times the IQR. So basically I'm saying this much, 1.5 times of that, 1.5 times of that, okay? If you're further than that far away from the first quartile, maybe you're an outlier, okay? So if something is smaller than this, would be an outlier, okay? what would be the calculation you would do then on the upper end if it's going to measure the same thing? Michelle? Good. You would look at the third quartile, and you'd say anybody who's more than 1.5 of those this way is probably pretty outside of what my scores are. Because remember, this is measuring the spread of the middle 50% of your scores. So if they are more than 1.5 times that spread past like that 3/4 of the way person, they're probably pretty far compared to the rest of your data. Not everybody uses this calculation, but it is a way if you're unsure, if you're like, I kind of feel like it's an outlier, it's a not, can I do anything else that might convince me? You could do this and see what you thought about it, okay? So it would be the third plus 1.5 times the IQR. And I'll write these up on the board because I think that some of you can't see them. And it would have to be bigger than this. So these are the two calculations that you're checking. They're giving you like boundaries where things past this on your box and whisker plot might be considered outliers. But again, sometimes they might not. You might be like, no, that's okay. I want to include that in my data because it's representative of this. This is like just an estimation. People said, you know what, this gives us a good spread. Let's say if anything was more than 1.5 times that spread away, maybe it's not the best piece of data. Okay? Are we okay with how to make things like this? Okay, so I'm going to give each group some data that you guys collected, and you guys are going to be in charge of making some stuff like this. Okay? So you can see that the next page has the same type of information. I'm also going to have you guys calculate the mean, median, mode, which we did yesterday, and the range. And then I included these ones in the box and whisker plot because those would help you create the box and whisker plot. You're only going to be doing one. Okay? And I'm going to split up the data for you guys.